Hello and thank you for your interest in our video. We are representatives from VTEPS Incorporated. My name is Will Vaughn, this is George Broomba, and Li Jing. Today we have the second installment of our design proposal for Newton Coaster.
Hello, if you haven't watched our video in the past, this is our current model. It's two obstacles, part of our Battle Frog Rube Goldberg machine. A Rube Goldberg machine, if you remember, is a series of obstacles that get together, make one machine that finishes or completes a simple task. For ours, we have currently built our loop and our collision, which is a Newton's cradle type device. As you can see here, this is our product management Gantt chart, which is outlining our schedule for the project. As you can see, the first 6 of our phases are already complete, and currently we're working on the design for manufacturing phase and the industrial design phase. Both of those are about a quarter of the way done, but we've already finished the first 6, including identifying customer needs or establishing target specifications, and those are included. The information from those is included in this DP2 project, and also, we have this economic analysis bar all the way across, and so that's really emphasizing how we want to look at the economics within our product throughout the whole time. So we want to analyze how this will make a profit the entire way. Inside the intellectual properties section of our DP2, we analyzed and researched multiple patents that could hinder or limit our product itself. And to give you an example of one of the ones that we found that was similar but would not have too much effect on how we would make it is the spiral toy track set. It's a patent on how the track is created and how it rotates. And there's a loop within it, but our product is only going to have a loop. It's not going to have a rotating track, and so that's how this patent will not limit our progress. But it gives us a good idea of something that we can look at and see what other companies have done before, and we can put into our product without copying theirs too much.
Concept generation and selection. In the beginning, we come up 3 ideas, and they are gravity, conservation of momentum, and centripetal acceleration. And then for each idea, we come up 3 obstacles. So we have total 9 obstacles. And look at those 2 pictures. The picture includes 2 parts. The upper part shows the ideas of obstacles, and the other part shows the picture of the real model. I will introduce product decompositions, and there are 3 obstacles, so we can divide it into 3 parts. And also for each part, we can also divide it into 3 parts. One is energy, one is movement, and one is action to cause the movement. So there's an example. We can look at the first part. First part is the poly. So for the energy is the potential energy converted to kinetic energy, and the movement is drop the ball, and the actions to cause this movement is to fall down the ball. So finally, we can find after the ball moves through the 3 obstacles, it will receive kinetic energies and move in the horizontally.
So before we decided which obstacles we were going to put into our Rube Goldberg machine, we went through a process called concept screening. So we had 9 different obstacles, 3 for each different concept, and we ranked them qualitatively on different criteria. So one was ease of construction and durability, and these both affected the success, or overall the success of the product, based on the satisfaction of the customer and low cost for our company. After we went through the concept screening process, we moved on to concept scoring. So the ones that made it through, we added weights to each criteria, and we assigned a value 1 through 5, 5 being the greatest in that criteria, and then gave it a score. And the ones with the highest scores we chose for our the obstacle to put into our Rube Goldberg machine. In the concept testing phase, we made a survey based on the prototype that we have come up with, and we put it out to a bunch of potential customers, some teachers, some students. And down here is a chart of the likelihood for them to purchase the item at $45. So some notable results from those surveys and suggestions that the participants put forth was bulk sales of the items for classrooms, and also making it one object per sort of activity, so that they could put each activity at a different table and have students roam around the classroom to get the full effect of the physics concepts. So after we have our prototype, we have to analyze some potential failures that might occur that might inconvenience or possibly endanger the customer. We determine the severity, the occurrence, the frequency of occurrence, and the detection rating, like how possible it is for the customer to notice an issue before it becomes a serious issue. And so based on those three criteria, we determine if any recommended action is necessary. And in here we had possibly the Arduino might fail because there's a loss of power, wires become disconnected. And so it wasn't a huge issue, but we can avoid that by hardwiring the Arduino instead of having them being able to be disconnected.
When demand is 1,750, our profit is maximum, and the total cost is about 82,500, and this is also the investment we need in the beginning. And for each quarter, our revenue is about 12,000. So this is also the payment we will pay for each quarter, and there are total 12 quarters.
As a result from our concept phases, we have decided that our team will build a pulley, a loop, and a collision inside our Battlefrog Rube Goldberg device. Currently, our team is working on the design for manufacturing and industrial design phases in our project. And to sum it up, our team believes that we need an $82,500 investment in order to pay the expenses for our product and create an investment over 3 years. I thank you for watching our video, and I hope to get back to you on the progress that we've made in the future.